So wrapping up the paper then, question 11, pretty challenging. So let's have a look at this. First two questions fairly straightforward, but then seems to ramp up fairly quickly for the final two parts. So in the first instance then, we have got this rational function here, 3x over x minus q, where x does not equal q. Write down the equations of the vertical and horizontal asymptotes of the graph of f. So to start off with then, it's easy to find the vertical asymptote. So to find the vertical asymptote, we are going to take the denominator and set it equal to 0. So if x minus q equals 0, we can say that x equals q. So that is the vertical asymptote. The horizontal asymptote then, to find that, we are going to divide the coefficients of x. So here 3x over x is going to give us 3. So the horizontal asymptote is going to be the line y equals 3. And part B, the vertical and horizontal asymptotes of the graph of f intersect at the point 1, 3. So if you imagine, we've got, we know the horizontal asymptote already is y equals 3, and we've got x minus q. So we can see that we've got asymptotes to the graph, and we know that these asymptotes both intersect at this point here. So clearly we can see that the horizontal asymptote is y equals 3, and if they intersect at these 2 points, this line here is the line x equals 1. So we can see that q must be 1. So if x equals 1, q is 1, so we can say that q equals 1. Part C then is where things start to get a little bit interesting. So we've got to the stage now where we can actually write the function. So we know that fx equals 3x over x minus 1. So what we can do in this instance is actually graph that just to give us a better idea of what's going on, and that looks like this. So we know from the previous question that the asymptotes intersect at the point Q, which has coordinates 1, 3. So this is the point Q. And then here we're told that the point P, xy, lies in the graph of f, and we're asked to show that PQ equals a root x minus 1 squared plus 3 over x minus 1 all squared, which is a little bit intimidating at first, but let's have a look how we can do that. So, suppose we've got some point here, which we'll call P, which is x, y. Essentially then, all we're doing is finding the distance. So we're just going to use the formula for the distance between 2 points, which is going to be the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And we can see that makes sense. This distance here at the base is going to be the difference between the x's. This distance here is going to be the height, the distance between the y's, and we can just use Pythagoras then to find this distance here. So we have a generic point x and y, so we need to now look at how we can get from this point here, this formula, into here. So if we look at our 2 points, we've got P, which is x, y, and Q, which is 1, 3. So I'm going to be looking at the square root of x2, which is going to be this point here, which is just x, minus x1, which I'm saying is 1, plus y2 is going to be y minus y1, which is the y coordinate of Q, which is 3. Now we can see at the moment I've got 2 variables, x and y, but up here we're being asked to show that PQ equals this expression, which is only in terms of x. So we've got to figure out how we can get from here into terms of x. Now fortunately, if we go back up here, we know we've already written down that fx equals 3x over x minus 1, and of course we can write y instead of f of x. So what I'm going to do now is then substitute that in. So I'm going to have x minus 1 squared plus, and instead of writing y, I'm going to write 3x over x minus 1 minus 3 all squared. So the next thing I need to do then is to try and get this second half here as a over a common denominator. So to do that, we can express that as x minus 1 squared plus, if I want it over a common denominator of x minus 1, that's going to be 3x, which is already over x minus 1, and then I'm going to have to multiply this 3 by x minus 1. And of course that is all squared. So if I continue and expand, that's going to give me root x minus 1 all squared plus 3x minus 3x is going to cancel out. Minus 3 times minus 1 is going to give me 3, so it's going to be plus 3 over x minus 1 all squared, which is what I'm asked to give up here. For the final part in question D, we're asked to find the coordinates of the points on the graph of f which are closest to 1, 3. Now 1, 3 we said is the point here, Q. So we are trying to find the location of this point here and via symmetry here as well, at which PQ is a minimum. So there are a few ways to do this. However, I think that the simplest way is to recognize that we are looking for the minimum value on PQ. So take our function PQ and graph it, which looks like this. So you can see that there are indeed going to be two minimum points. So this one here we can see is going to be when x is negative 0.732, and this one here is going to be when x is 2.73. The other way you could have done this question was recognize that for PQ to be at a minimum, the derivative of PQ would have been equal to 0. So you could have done it that way, or on your calculator graphed it and seen where the derivative was equal to 0. But as I said, just graphing PQ and using the analyze graph tool to find the two minimum points is the simplest way to do this. And remember that we are asked for the coordinates, so you need to give both sets of points. So negative 0.32, 2.45, and 2.73, 2.45.